Hi Tejaswini. Good evening. Am I audible, right? Let me know in a chat box once. Yes, thank you so much. Hi everyone. Good evening. Good evening, Nageshwari. Good evening, Swastik. Yeah, good evening, Manthan. Good evening, Prakriti. Yes, guys, how are you all? I think you are the one who pronounced my name correctly. Why Swastik? Yeah, I'm also fine. Okay, guys, shall we start our class? Capacitors. We are already using the capacitors in our syllabus. Since from last 2 days, we are in the capacitor chapter, right? Right? Okay, guys, I think 30 members came. Sir, D pencil option is on. D pencil. What is that D pencil? Yeah, I got it. Got it, Rajat. Rajat, got it. Okay, cool, buddies. Still 13 members are there. Yeah, we'll start, guys. Okay, we'll take a quick recall about the last class, previous class, and then we're going to continue the class. Okay, and previous class we discussed about the parallel plate capacitors, right? In that parallel plate capacitor, we discussed the capacitance of the capacitor mainly, right? That is capacitance of the capacitor we got A epsilon naught divided by D. Right now, this is for a parallel plate capacitor. Generally, we know that capacitance can be calculated by using the formula Q by V. Right, what I'm saying. And here in a parallel plate capacitor, the capacitance is depending upon the area and distance between our two plates, that is what D, and epsilon naught, that is a medium between our two plates. Correct. Now, if area is increasing means capacitance also increasing, but in the sense of D, distance between our parallel plates, if you're going to increase means capacitance go on decreases, right? And later on we discussed the series combination of capacitors. In series combination, what we did, the two all about the parallel plate, we did parallel plates series connection, right? After then we found out the equivalent capacitor, means instead of these three capacitor we can replace only one capacitor. Correct. Now that too we called as an equivalent capacitor. That equivalent capacitor value will come out to be 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Right. These are equivalent capacitors. Here we are going to addition, means we are going to add the capacitance inversely, right? reciprocal addition. Simply we can say it's a reciprocal addition. Correct now, n number of capacitors are there means we can add n number like this one. But the final capacitance will be less than the each capacitor what you're going to connect it there. Now, suppose yesterday I given an example, you might be see here. Look at this portion. Okay, I given two example. If I connected 2 microfarad, 2 capacitors in series means final equivalent capacitance we got only 1 microfarad, right? That's great. And then next thing is that connection in a parallel. Okay, in parallel combination. And one more thing, in series combination, charge is same. Charge same in series combination. But here charge is actually dividing. Here charge, hey, it is also series connection, right? Sorry, buddies. I think it is missing here. Okay, parallel combination is missing here. Parallel combination like this, right? What we done? We connected the 3 capacitors in parallel like this with an external battery. Okay, here charges are divided Q1, Q2, and Q3. Right. After finding the charges here, total charge will be equals to Q1 plus Q2 plus Q3. By using this formula, actually we write here, we have to calculate here capacitance means C is equal to Q by V. Charge we need to calculate means Q is equal to CV. If you put this equation inside here means we will get here capacitance means equivalent capacitance as an C1 plus C2 plus C3. Correct now, but in an equivalent capacitance, guys, if you're going to connect it parallelly, okay, equivalent capacitance we will get more than that each capacitance. Is there any doubt up to this point? Let me know in a chat box quickly. I'm asking everyone. Hello, are you there? Only Rajat given a response. Bharat, Chandana, Devegowda, Gayan. Gayan, where are you, bro? Yes, Nageshwari, right? Good. Purnima, Prakriti, Sagar, Swati, Krishna. Yes, that's great. Okay, great guys. Then today we're going to learn about the spherical capacitors. Okay, do you know what is spherical capacitor? Sphere. Okay, here previous example of parallel plates means we took 2 plates of each area like this. Correct now. And one more point I want to tell you here. It's very important, guys. Very important. So no answer. Here parallel plate capacitor we kept like this with some separation distance D. Okay, for this capacitor, yeah, I will tell you, Rajat, wait. Okay, capacitance we got A epsilon naught divided by D. Correct now? Okay, it is good. And then next thing is that here area means what you will do? You will calculate length into breadth of the plate. Yes, I will agree with this one. What about the sphere? Not in a spheres. If I'm going to take circular plates, this is actually rectangular plates. Correct now? These are actually rectangular plate. Okay. What if I'm going to take the circular plates like this? This is one plate. This is another one plate. Okay. Is there any chance to make like this capacitor? Arey yaar, so just what you are saying. Circumference, huh? Tell me that if I connect these two to the external battery like this, okay, we can say this is also capacitor with a small distance only. We can say it's a capacitor. Is it capacitor? Is it will be a capacitor? Yes, yes, yes. It is also a capacitor. Correct now. If it is capacitor means then capacitance will become A epsilon naught divided by D as itself. But here area we are going to replace this one by pi r square. Okay, just a small difference. Clear now? Is it clear? Yes. Yeah, then we'll move to the interesting topic, that spherical capacitors. Sphere means, you know, right, three-dimensional wala. Okay, three-dimensional means मान लो just two balls. Okay, this is one cricket ball, inside one yellow color, outside one is a football, like that. Okay, these are not have a wide range of application. Why I will tell you later on. Okay, these are not having a wide range of application in our daily life, but we need to study this one because of exam mein पूछता है questions पूछता है, that's why. Okay, length, breadth and height. No. Wait bro, wait. Okay, inner surface is there, no, इसका radius है मान लो r1. Okay, outer radius है this one r2. This one is r2. Now if I'm going to take this point as a, this point is b. Now what I will do, I will connect these two plates to a battery. Means inside wala I will connect to the positive battery terminal, and outside wala I will connect to the negative terminal battery. Now inside what will be happen? It will be charged with positively charged particles. Is it visible? This color is visible, right? Is that color is visible? Green color, what I wrote on that. Okay, then outside one will be get charged with the negative. Okay, done. Now we need to calculate the capacitance of this spherical capacitor. मान लो capacitance we need to calculate means we have only one formula, that is C is equal to Q by V. Okay, done. Q is equal to C by V. चार्जेस तो पता है हमको, इसके अंदर चार्ज कितना है, प्लस चार्ज है माइनस चार्ज भी है, करेक्ट ना. नाउ वी नीड टू फाइंड आउट द पोटेंशियल. पोटेंशियल क्या होता है, दोनों के पास चार्ज है मींस उसके पास पोटेंशियल भी होता है. फर्स्ट क्लास ऑफ द सेकंड चैप्टर आई टोल्ड यू, करेक्ट ना. ओके, मान लो आउटर सरफेस स्फीयर है ना वी ए, ये के पास, ओके उसके पास पोटेंशियल है वी ए, एंड इनर स्फीयर है ना उसके पास पोटेंशियल है वी बी. We know that one equation where actually dv is equals to minus E is equal to minus dv by dr, right? Sorry, it's by my mistake. Okay, कोई problem नहीं. Relation between electric field intensity and as well as the potential. E is equals to minus dv by dr. Now we can solve the potential difference. We want potential means we can solve from here only, because potential कैसे आता है, मान लो from here से in this direction we need to bring one positive charge, means we need to work on this positive charge, correct ना. Work done per unit charge only potential, work done per unit charge only potential. For that reason I took, if I'm going to take this one to left hand side, then देखो इधर minus dv is equal to E dr, correct ना. Now सुनो, ध्यान से सुनो, what I will do now. Okay, what I will do now, actually I will calculate this one by using the Gauss theorem. Gauss theorem क्या बोलता है, मान लो this is the point P. At this point if I want to calculate the field means, okay, what I want to do now, I want to draw one Gaussian surface. This is also a spherical surface. देखो क्या कर रहा हूं मैंने, spherical surface है. Okay, this point is located at a distance of r, मान लो r distance में है, correct what I am doing. Meanwhile guys, if you are getting any doubt please let me know. Clear है ना. Okay, now according to Gauss theorem guys, flux के लिए एक equation था in a closed integral, E dot ds is equal to q by epsilon naught, यही था ना. Okay, now flux we don't want, we need to calculate the E value because I need to put here. That's why in this equation number 2, equation number 1, in equation number 2 I need to substitute E. That's why I will calculate E value. देखो, if I take E outside means it is an integral of ds is equal to q by epsilon naught. Guys, देखो इधर, this is a Gaussian surface, it has a radius r. Then guys, may I know what will be the total area? This is small area ds. Okay, then may I know what is the total area of that one? Yes, right. Total area क्या होता है? Key area of sphere. That's a smart answer. Okay, I will write only. E into area of the sphere is nothing but 4 pi r square is equals to q divided by epsilon naught. 4 pi r square is the area of the sphere. Correct now? Then E value take right hand side, then it will become q divided by 4 pi epsilon naught into r square. Done, right? Up to this point, I think everybody got the things what I derived. Yes, Rajat. Clear now up to this point? Once again, देखो bro. Okay, I need to calculate the potential here. Potential calculate करना. Potential calculate करने के लिए मेरे पास एक इक्वेशन है, E is equal to minus dV by dr. Correct ना? Here potential means bringing one unit positive charge from infinity to that field. एक field के अंदर लेके आना है charge को. Means here I want to bring means ये potential find out करने के लिए equation ऐसे रखूंगा मैं. Okay, dV is equal to E dr because here potential will be, इधर देखो VA है, इधर VB है. ये potential difference के वजह से we can bring the charge only. That's why, right? What I'm saying. Now I need to calculate the value of E. E value calculate करना है. That's why what I'm doing here, I will consider one point inside this sphere. It is between a two spheres. At this point, it is at a distance small r. I don't know that r distance. Okay. At this point, I will draw one Gaussian surface. By using Gaussian surface, I will calculate the value of E. Gauss law क्यों use करते हैं हम? Calculation of electric field intensity only, right? Right? According to Gauss law, we will write the electric field intensity equation like this. Flux value is equal to a closed integral E dot ds is equal to q by epsilon naught. Here ds value we need to means E is a constant, take it outside. Ds means small area. If I'm considering this is a small area, means if I integrate whole Gaussian surface small area, complete Gaussian surface integrate करने से मुझे 4 pi r square मिलता है. R square means Gaussian surface radius है, and it is equal to q by epsilon naught. Then E value we got like this. Correct now? Now I will substitute this E value in this equation. ये equation के ऊपर substitute करता हूँ मैंने equation number 2 के इधर. Clear हाँ? देखो इधर again dV is equals to, I will multiply minus here, minus of E dr. Okay, E dot dr. Correct now? It is actually cos theta function है. Correct now? Minus E dr cos theta. देखो guys, due to positive charge at this point, a point है ना, point के ऊपर electric field will be moving in this direction. Electric fields are moving outward direction. We are bringing a positive charge opposite direction. Yes, theta value become here guys 180 degree. Yesterday only I told you 180 means cos 180 means minus 1 होता है. Cos 180 means minus 1 होता है. Yes, that too good. If I substitute that value here means dV value will be comes out to be E dr cos theta minus 1. Clear now? E dr we got. Up to clear, right? Okay, next thing is I'm deriving in the next page. Okay, keep concentrate. We got one more equation, dV is equal to E dr. Okay, now I will substitute this E value here. Okay, q by 4 pi epsilon naught into r square. Clear enough? Is it clear? देखो, ध्यान से देखो. E value we got q divided by 4 pi epsilon naught into r square. dV value we got E dr. Now I will substitute this value here. dV is equals to, in the place of E, q by 4 pi epsilon naught into r square into dr. Correct now? dv is there. We require potential to calculate the capacitance of the capacitor, that is q by v. v chahiye means here dv है, small amount of potential. Throughout the potential कितना है कैलकुलेट करने के लिए क्या करना है, इंटीग्रेट करना है. ओके कर दूंगा इंटीग्रेशन. पर इंटीग्रेशन करने के टाइम में एक्चुअली dv था पोटेंशियल एट दिस पॉइंट का. इंटीग्रेशन करने के पॉइंट क्या क्या है मींस पॉइंट ए टू पॉइंट बी तक करना है. पॉइंट ए टू पॉइंट बी, दिस आर द टू सरफेस distances, right? That's why means here first surface का radius है r1, means b के ऊपर r1 है, and then a के ऊपर radius है r2, right? What I am saying means we need to integrate from r2 to r1. This much distance we need to integrate. Integration का limit भी होता है देखो थोड़ा. Okay, here it will be from r2 to r1, right? Okay, I'm going to integrate dv. I will get total voltage v is equal to q 4 pi epsilon naught. This all the things are constant, guys. Take it outside of the integration. Q divided by 4 pi epsilon naught. Remaining thing will be r2 minus r1 1 by r square into dr. Correct now? Now I will check who will give the first answer to me in a chat box. Okay, what is the integration of 1 by r square? 1 by r square का integration क्या होता है? अरे यार सुन रहे हैं ना? If you don't know means tell me, I will explain you also. So see which answer I need to take, bro. 1 by 2. Okay, if you don't know means just no need to hesitate, just let me know. I will integrate this one in a easiest way and I will tell you how to integrate this one also. देखो इधर if function देखो ध्यान से देखो इधर x, I will give a explanation. If x square into dx hai, just imagine like this. If I'm going to integrate this one, no, what I want to do, x square is there, no, and then we need to add 1 plus 1 in denominator. Same we need to write 2 plus 1. Okay, it is nothing but x to the power of 3 divided by 3, right? In a similar way, if in case 1 by x square is there, 1 by x square, now you try to take this one to numerator, then it will become x to the power of minus 2 into dx. Correct now? Similarly, we need to do the calculation here. Now x to the power of minus 2 plus 1 divided by minus 2 plus 1. Correct now? Minus 2 plus 1 means it is nothing but x to the power of minus 1 divided by minus 1. Simply we can write again. If I'm going to take this one to downward direction, no, it will become minus of 1 divided by x, means 1 by x square का difference integration होता है minus 1 by x. Is it clear? Yes, Gayan. We can write RS minus 1 by x itself. Clear? Clear, right? Good, good. Good, good, everyone. Okay, I will rub this one. I will rub this one. Take a screenshot if you want, means take a screenshot. 1, 2, 3, done. Okay, now tell me what is the integration of 1 by r square now? 1 by r square का integration क्या होता है? Minus 1 by r, means potential value comes to be q by 4 pi epsilon naught into minus 1 by r, integration limit from r2 to r1. Correct now? Next we need to apply the limits. Limit apply करना है. Then v value will come out to be, next I will solving here q divided by instead of that in a order I will solve. Okay, it is not good. देखो इधर, okay, V value will be Q divided by 4 pi epsilon naught. Upper limit means minus capital 1 by R1. Okay, lower limit minus है, minus into minus becomes plus, minus of lower limit we have to apply, divided by R2. Correct ना? I will swap this one. Okay, दोनों साइड से swap करूंगा, means interchange करूंगा. Then it will be V is equal to Q divided by 4 pi epsilon naught 1 by R2 minus 1 by R1. Correct now? Next step, take LCM here. Take LCM. When you're going to take LCM, Q divided by 4 pi epsilon naught R1, R2 as an LCM. Remaining thing will be R1 minus R2. Clear enough? This is actually what we got. Potential. Potential we got. If I want to calculate the capacitance, means in the place of capacitance, we need to substitute this V value. Right? देखो, simple सा है, कुछ भी नहीं है. Okay, capacitance we will get here. Capacitance C is equal to Q divided by, in the place of V, we need to substitute this one. Q divided by 4 pi epsilon naught is there. If it is comes to numerator means 4 pi epsilon naught. 4 pi epsilon naught. इधर भी ये दोनों इंटरचेंज होता है. इंटरचेंज होने से R1 R2 divided by R1 minus R2. Okay, either Q cancel, then capacitance will be depends on here 4 pi epsilon naught R1 R2 divided by R1 minus R2. Is it clear? Guys, is it clear? Why sir your dog is crying? Actually I'm talking with you people, no. Actually it is in front of me only. But I'm talking only with the laptop. I think the dog is thinking like that. मुझे या ये तो पागल है, एक ही बात कर रहा है, ऐसे थिंक कर रहा है वो डॉग. कॉन्सेप्ट क्लियर है ना? ये बोल दो. दिस इज इंपॉर्टेंट. गुड. गासला अप्लाई करने का तरीका सीखो. लास्ट 2 स्टेप्स. ओके, अभी देखो इधर. लास्ट 2 steps means one thing we got here, potential. Correct ना? Potential we got means we required capacitance, means capacitance को सबके लिए एक ही है, Q by V or else small q by V. V के प्लेस में इसको सब्स्टिट्यूट करो इधर. If I'm going to substitute means V Q divided by V क्या है देखो, Q divided by 4 pi epsilon naught, इधर R1 minus R2 divided by R1 R2. Q cancel. This is numerator, this is denominator. Denominator में R1 minus R2 है. This is denominator of the denominator. These things will comes to numerator. Okay, when these things will comes to numerator, equation will become out to be in this format. Clear now? We'll go further. Okay, देखो इधर एक क्वेश्चन दे दूंगा आपको. ओके, क्वेश्चन क्या है? द डायमीटर ऑफ ईच प्लेट ऑफ अ एयर कैपेसिटर इज 4 सेंटीमीटर. टू मेक द कैपेसिटी ऑफ अ प्लेट capacitor equal to that of 20 centimeter diameter sphere, the distance between a plates will be. Okay, I think do one thing guys, please go through the problem once. Okay, I will solve my dog problem also. Just 1 minute, just a minute. Guys, Did you got the answer? Yes, right, Jansi. Awesome. Guys, parallel plate, sorry, spherical plate capacitor है ये. Capacitance क्या होता है? Capacitance is equal to A epsilon naught divided by D. Correct now? Now we need to calculate the distance between our two plates. The two, what kind of capacitor it is? देखो इधर प्लेट्स कौन सा है, डायमीटर में पूछ रहा है वो. करेक्ट ना? In terms of diameter they are saying. Correct ना? Diameter of the capacitor is this centimeter, means diameter is 4 centimeter, means it is actually circle plates. Okay, plates are circle, not a rectangle here. Okay, area क्या होता है इधर? Pi r square, but r we required means d को क्या करना पड़ता है? Divided by 2 करना पड़ता है. D by 2 will gives the r value. Correct now? Okay, we'll calculate. Okay, capacitance will be equals to area means again pi into r. Sorry, one second, guys. Just a minute. Sphere, right? Okay, this is sphere bhi hai. Sphere hai means, sorry, yesterday we calculated sphere equation also. Okay, capacitance of the sphere. देन एक बार रिवाइज कर लो, क्या हमको मिला था? 4 पाई एप्सिलॉन नॉट आर. एप्सिलॉन नॉट आर, आर के ऊपर डिपेंड होता है कैपेसिटेंस, बोल दिया था मैंने. करेक्ट ना? दैट वन विल बी इक्वल्स टू हियर, क्या है इधर? ये एप्सिलॉन नॉट डिवाइडेड बाय डी. नाउ वी नीड टू कैलकुलेट द डी. नो, टेक इट टू लेफ्ट हैंड साइड. देन डी वैल्यू विल बी कम्स आउट टू बी ये एप्सिलॉन नॉट डिवाइडेड बाय 4 pi epsilon naught into r. Correct now? Epsilon naught cancel, right? Then area के लिए क्या लिखना है हमको इधर? pi r square divided by again 4 pi r is there. Pi cancel, 1 r cancel, remaining thing will be here r by 4. Correct now? We know diameter 4 centimeter. R means क्या होता है? Divided by 2 होता है, again divided by 2. It will be nothing but D का value 4 है, divided by 2 means 2 centimeter divided by 4 आ रहा है. Correct now? Is there anything we did wrong here? Check it once. I'm getting wrong answer. Yes, we did wrong here. Just a minute, guys. Sorry for that one. R square. This is R. 4 pi epsilon naught. Where we did a mistake. Cross check it once. No. Actually, we will get an answer D. D है correct answer. Cross check करो. If I did any mistake means. Same ही था ना equation तो सब कुछ. A dog कुछ है. Okay. This is the capacitance of the capacitor. Just a minute, I will check. Four pi epsilon naught A epsilon D. Okay, D if I want to calculate means A epsilon naught by 4 pi epsilon naught into R. Okay, epsilon naught cancel हो गया. And where is the mistake? ढूंढ लो यार एक बार. ऑप्शन डी आना चाहिए. C. No, not C. mistake. Yes. Here we made a mistake, guys. Okay, I will tell you where is that. Epsilon r, I think. No. Everything is correct only. Everything is correct. A epsilon by 4 pi r only. Okay, area is a, actually it is a capacitor plate wala. Okay, diameter दे दिया है ना इसका, but here 20 centimeter भी दिया है. Diameter of the sphere they are saying. Diameter of the sphere. देखो इधर क्लियर कर दूंगा, स्टार्टिंग से क्लियर करता हूं मैंने. कैपेसिटेंस के लिए यही फॉर्मूला है ना, राइट. नाउ देखो, दिस इज फॉर, वी नो वन मोर पॉइंट फॉर दिस स्फीयर. ओके, कैपेसिटेंस क्या होता है, 4 पाई एप्सिलॉन नॉट इनटू आर होता है, करेक्ट ना. इज इक्वल टू, हियर क्या है, ये एप्सिलॉन नॉट डिवाइडेड बाय डी इज देयर. डी वी नीड टू कैलकुलेट. एप्सिलॉन नॉट कैंसिल हो गया. हियर स्फीयर का डायामीटर दे दिया है 20 सेंटीमीटर. 20 सेंटीमीटर का डायामीटर है स्फीयर. ओके, वी रिक्वायर्ड आर मींस वैल्यू क्या होता है, उसका आधा होता है, right. Half of it will be happen, no, diameter of the sphere also. Then d we want to calculate means take this d to right hand side, then it will be a epsilon नहीं is there, no, and divided by 4 pi r, correct ना. area of the this one किधर है capacity of the plates of the capacitor का diameter है, means circular plates का. okay, area of that circular plate is nothing but here pi r square. pi r square divided by 4 pi r. Pi cancel, no, and then here r square means it is the radius of the plate. This is plate, guys, this is plate. radius का plate है, कितना दे दिया है, diameter दे दिया है 4 सेंटीमीटर, करेक्ट ना. radius कितना होता है उसका, 2 सेंटीमीटर, means 2 into 10 to the power of minus 2 we can write now. We can write whole square. Now it will become meter. Are you understanding right what I am doing? इधर in denominator में क्या है, 4 into r. They given diameter of the sphere. Sphere का diameter है, हमको चाहिए radius of the sphere. okay, उसके आधा होता है, means 10 into 10 to the power of minus 2, means एक मीटर को कन्वर्ट हो गया. नेक्स्ट थिंग क्या है, देखो, 2 here 4 into 10 to the power of minus 4, डिनोमिनेटर में 4, एंड हियर 10 to the power कितना होता है, minus 2 है, this is plus, it will be 10 to the power of minus 1. this 4 cancel, then 10 to the power of minus 1 becomes to numerator, is 10 to the power of minus 4 into 10 to the power of plus 1, but 10 to the power of minus 3. It is under that, guys. Clear now? 10 to the power of minus 3, nothing but 1 into 10 to the power of minus 3, right? Right, what I'm saying. Did you understand, right? Is it understood? Guys, are you there? Okay, cool. It's pretty well. Okay, we'll go further. Okay, now guys, देखो, up to now we discussed about the capacitor, correct now. We also know that capacitor stores the electrical energy, correct now. Capacitor stores the electrical energy, right now. Now we need to calculate how much energy this capacitor will store. Okay, that is the concept now, right? We'll go through that one. ना डिस्टर्बेंस है इधर. ओके, देखो इधर, मान लो these two are the capacitor plates. okay, now if I'm going to connect these two to the external battery, they are get charged means inside them there is a energy is started to store, correct now. Inside energy started to store, correct now. Now we need to calculate the energy. देखो क्या कर रहा हूं मैंने, the process of charging of a capacitor equivalent to transferring the charges from one plate to another plate of the capacitor. Done. The moment of charging starts, there is a potential difference. Means going to charge, no, that time there is a potential difference. ये दोनों का बीच में means इधर V है, means इधर 0 से start होता है. First charge 1, charge 2, charge 3, like that the potential will be start. Potential will be increase होने के start होता है. Therefore, the transfer of charge against the potential difference, some work is to be done. Means देखो यार, इधर पोटेंशियल V वोल्ट मान लो 9 वोल्ट था. ओके, 1 मिनट के बाद में ज्यादा ले रहा हूं, कैपेसिटर विल बी गेट चार्ज वेरी फास्टली. ओके, बट जस्ट फॉर दी कन्वीनियंस करने के लिए बोल रहा हूं मैंने. मान लो 1 वोल्ट हो गया, 1 वोल्ट में इतना चार्जेस स्टोर हो गया था, चार्जेस ऑलरेडी स्टोर. नेक्स्ट 2 वोल्ट के लिए अगेन चार्जेस स्टोर, 3 वोल्ट के लिए अगेन चार्जेस आर स्टोर. मींस इधर ऑक्यूपाई हो रहा है, जगह पूर्ति ऑक्यूपाई हो रहा है. नाउ to move some more voltage to on this plate, here battery should do some external work done. Some external work done करना पड़ना है इधर. Okay, external work the battery has to do to store the charge on the plates. Simple है यार. मान लो this is actually van. Okay, मान लो this is van. Okay, 3D मान लो guys. Okay, I can't able to draw that one. Okay, this is a van. Guys, इधर आप है. Okay, तुम्हारा पास पोटेंशियल है. मान लो आप है बैटरी. इधर बहुत लोग आ रहा है, उसको क्या करना है आपको, इसके अंदर ढकलना है, इसके अंदर मूव करना है. Okay, you will move 2 peoples, 3 peoples. It has a capacity मान लो 100 members. 50 members, when it will be filled with the 50 members, that time already sufficient होता है इसके अंदर. Again आपका काम क्या है, ये remaining 50 members को भी इसके अंदर फिल करना है. फिल करने के वक्त क्या करना पड़ता है आपको, वर्क करना पड़ता है इधर. करेक्ट ना. इन अ सिमिलर वे हियर चार्जेस को प्लेट के ऊपर रेस्ट करने के लिए, मींस प्लेसिंग करने के लिए बैटरी को क्या करना पड़ता है, वर्क करना पड़ता है. Are you getting my point what I am saying? Let me know in a chat box. Let me know in a chat box once. To store the charges on capacitor plates, battery को extra work करना पड़ता है. That work is there. No, we know one equation. Work is nothing but energy. We people already studied this one in the 11th standard. This work, what the battery will do on this charge storing करने के लिए, it will be saved as an energy. It is saved as an energy. Energy के रूप में सेव हो जाता है. That is we called energy stored in a capacitor. Clear now? Clear, right? Concept clear? एनर्जी कैसे स्टोर होता है, कॉन्सेप्ट क्लियर ना? यस, दैट टू ग्रेट. देखो, द वर्क डन स्टोर्ड इन अ इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी इन द कैपेसिटर. वर्क इज स्टोर्ड एज एन इलेक्ट्रोस्टैटिक पोटेंशियल इन द कैपेसिटर. ओके, if dq amount of charge transferred against the potential difference, then the work done is given by. कैसे वर्क डन कैलकुलेट कर सकते हैं आप, देखो इधर मैंने बोलता हूँ. ओके, देखो dq amount of work done हमको पता है, work done is equal to RS. We know potential is equals to work done by charge. Now we want to calculate work done, means work done is equal to charge into potential we will do. Correct ना? मान लो इधर छोटा सा चार्ज है, means dq amount of charges are stored here on this one, means total charge था q. dq amount of charges store हो गया, means ये dq amount of charge store होने के लिए कितना amount of work करना पड़ता है, dq amount of work करना पड़ता है. करना, dq amount of charge स्टोर करने के लिए dw amount of work करना पड़ता है. रिवर्स है गाइस, सॉरी रिवर्स वाला था. करेक्ट ना? देखो, similarly here dw amount of work we need to do on a plate of a capacitor to store the dq amount of charge. dq amount of charge. करेक्ट ना? ओके, नाउ इधर देखो, v का वैल्यू क्या होता है, पोटेंशियल. करेक्ट ना? व्हाट आई एम राइटिंग, पोटेंशियल. पोटेंशियल के लिए इक्वेशन क्या होता है, Q by C. Is it right? How it came? How it came? Q by C. Is there anybody know? Let me know. How I write Q by C? Do you know, guys, why, how I took this Q by C? अरे यार रात ಎಲ್ಲ ರಾಮಾಯಣ ಕೇಳಿ ಹಗಲಲ್ಲಿ ಏನೋ ಕೇಳಿದ್ರು ಅಂತ अरे यार this is capacitor, guys. Capacitance of the capacitor क्या होता है? Q by C only, right? Sorry, Q by V. Q by V. If I want to write V means V is equal to Q by C. Karma. Guys, illidira illa. This is from the capacitance of the capacitor. V we replace it by Q by C into dQ. This is equation gives dW amount of work done. Now we need to store the charge. कितना स्टोर करना है चार्ज को? Q amount of charge को स्टोर करना है, not dQ. dQ is a small amount of charge. Q amount of charge स्टोर करने के लिए ये dQ amount of charge कितना होता है ना, dQ dQ dQ, ये सबको ऐड करना पड़ता है. Correct? It is nothing but integration. इंटीग्रेशन कर लो. देखो इधर दोनों साइड इंटीग्रेशन कर दिया मैंने. On integrating both the side, dW value will be comes to be W is equals to either 1 by C is a constant, capacitance constant होता है, take it outside, and integration of Q into dQ. इंटीग्रेशन किधर से किधर तक करना है? 0 to total charge Q तक करना पड़ता है. That is what directly I written here. Correct? Now here this work done, guys, work done already we discussed that it is stored as an energy के रूप में स्टोर हो जाता है, right? And then देखो नेक्स्ट स्टेप क्या करता हूं मैंने, करने क्या है, इधर आंसर ही आ गया. देखो इधर 1 by C Q integration. May I know what is the value of integration of C? Sorry, integration of Q. If I do integration of Q, what we will get? Q के लिए इंटीग्रेशन करो, इंटीग्रेशन करने पे +1 करना है डिवाइडेड बाय सेम इधर रखना है. करेक्ट ना? लिमिट तो 0 to Q तक होता है. देन देखो वर्क डन वैल्यू विल बी इक्वल्स टू 1 by C. इट इज नथिंग बट गाइस Q to the power of 2 divided by 2. If I am going to apply the limit, Q is replaced by Q only. Correct? Then total work done will be comes to be 1 by 2 Q square C. This is the guys actually work done you need to do on the plates by the battery. Okay, this work done is stored as an electrical potential energy. Clear now? Stored as an electrical potential energy. Clear? This is scale kata natak band bolta hai na वैसे. Is that clear? This is the energy equation. Energy stored in a capacitor plates. Tell me in a chat box quickly. I got only few responses. I'm expecting maximum, guys. Only 20 members are there, few people. Yes, that's great. That's great. C is in denominator. Okay, okay. This, I wrote here mistakenly. Okay, it should be Q square by C. Okay, one format हो गया. If देखो इधर सुनो guys, सुनो. अरे यार आंसर ही आ गया था. Okay, we know that Q is equal to, guys, Q is equal to C into V. Correct now? Capacitance equation. If I put this equation in this equation, means what I will get, this work done value or total energy stored in this value will become to be 1 by 2 Q के replace करो, C square V square, Q square है, divided by C. Then C get cancel. Then remaining thing will be here 1 by 2 C V square. 1 by 2 C V square. This is also an equation for electrostatic potential energy. Clear now? Good, good, good. And one more equation also there. In a similar way, if I'm going to substitute, means we will get half QV also. Where we need to substitute, that is very important. Here you substitute the Q value here, correct na? Numerator में Q value substitute किए थे, right? If I'm going to substitute the C value here, C value क्या होता है guys? देखो इधर मैं substitute करता हूँ मैंने. C is equal to Q by V, Q by V ना. Then देखो the work done is equal to equation था of Q square by C. C के ऊपर ये equation इधर substitute करो. Then work done will be equals to of Q square divided by C means Q divided by V means it will comes to numerator. Q cancel 1. Work done will become to be of QV. This is also an equation for the energy stored in a capacitor. Is that clear? देखो 3 इक्वेशन आ गए हम. ये तीनों इक्वेशन आप नोट करना है. फर्स्ट वन विल बी ऑफ CV स्क्वायर, sorry, of Q square by C. Second one will be of CV square, and third one will be of Q into P. All done. Good, good. Okay guys, this is all about the energy stored in the capacitor plates. Next will come out to be one more interesting topic guys. Today I'm going to finish after this topic. Okay, next topic is that energy density. आपको mass density पता है ना? Mass density, it is nothing but density itself. Density क्या होता है? Mass by volume. Correct ना? This is we called mass density. Charge density 3 types का होता है. Linear charge density, surface charge density, volume charge density. Yes, that too great. Correct, Ashwini. Okay, in a similar way, we need to calculate the energy density. Energy density क्या होता है? देखो इधर. Of CV square, it's a energy. Correct ना? And then we need to calculate density now. Density calculate करने के लिए मैं क्या कर रहा हूँ इधर? First, I will take a value of C. C value पता है ना? Capacitance of the parallel plate capacitor. मान लो ये पैरेलल प्लेट्स का डेंसिटी ओनली निकाल रहा हूं मैंने. ये दोनों को बीच में एनर्जी स्टोर हो गया है. एनर्जी वैल्यू विल बी ऑफ CV स्क्वायर. ओके, ऑफ CV स्क्वायर. ये वॉल्यूम, इफ आई एम गोइंग टू कंसीडर दिस वॉल्यूम, इतना वॉल्यूम में कितना डेंसिटी है, मींस एनर्जी कितना है, दैट इज नोन एज द एनर्जी डेंसिटी. C वैल्यू पता है हमको. एंड देन इक्वेशन E इज इक्वल टू B पता है. Why I'm taking these all things? Because I need to calculate the energy density. How? देखो इधर C है ना, C के अंदर इसको सब्स्टिट्यूट करो. V है ना, इधर भी V है, इसके अंदर इसको सब्स्टिट्यूट करना है. देखो क्या आता है, कैलकुलेट करता हूँ. U value will be equals to be of C means ये epsilon naught divided by D into V square. इसको स्क्वायर कर दो, then it will be E square into D square. इधर एक D से एक D मर गया. Then energy density value will become to be of ये epsilon naught E square into remaining thing will be here only D. Correct ना? हमको पता है एनर्जी डेंसिटी मीन्स एनर्जी पर यूनिट वॉल्यूम लेना है. एनर्जी पर यूनिट वॉल्यूम लेना है. That's why what I will do, इधर A stands for area, D stands for any one length. A is an area and D is an unit length. Correct now? If I multiply these two means what I will do, what I will get, area into one length. Let me know in a chat box. If I multiply this, we will get good. We will get here volume. If I multiply these two means we will get volume. Correct now? Means I will take these two terms left hand side, then it will be energy divided by AD will be equals to of remaining क्या है इधर E square into epsilon naught. We call this one as an energy density. Okay, energy per unit volume. We can replace this one by symbol like this, U dash. U dash stands for energy density, guys. Energy density. Okay, then energy density के लिए formula क्या आता है? Of E square epsilon naught. Of E square epsilon naught. Correct now? And then if they are asking what is the dimension, sorry, what is the SI unit for the energy density? Okay, don't go through this equation to solve. Okay, this is actually neat question. SI unit of energy density will be joule per meter cube. इसका dimensional formula पूछता है. When dimensional formula पूछता है ना, that time what you people will do, you will try to remember the formula of energy density. Sir बोला था energy density means half E square epsilon naught. Okay, E square के लिए क्या है? Force into charge है. Epsilon naught के लिए क्या है? Like that you will start to think. No need to start to think like that. Energy density means it is nothing but energy per unit volume. Correct ना? Energy के लिए SI unit होता है joule. Volume के लिए SI unit आता है meter cube. This is the SI unit of energy density. Okay. If you want to write the formula for this one, no, take this one itself. Joule के लिए kg meter square per second square divided by meter cube. Meter square meter cube में ये 2 मीटर कैंसिल हो गया. Remaining thing will be kg. If 1 meter comes to numerator means be -1. इधर +1 था ना. If this comes to numerator means -1. Here in the numerator -2. Okay. By the, now we simplify all the things. These are all in our fundamental quantities. Now we need to raise the power of m, l, t. Mass to the power 1, length to the power -1, time to the power कितना है देखो -2. This is the dimensional formula. Is clear, right, for everyone? Tell me next quickly. How was the session? How you enjoy? Sorry guys, actually there was a internet issue. Tell me in a chat box, guys, is that everything is clear, right? What I thought. Hello, are you there? Akila, Bharat, Captain, Abhi, Sagar, Sinchana, Krishna, Yashaswini, Yatish, Mandya. Is that clear to everyone? Okay. Okay, guys. Okay, guys, this is all about today's one. Okay, we'll meet you on Monday. Okay, well, bye-bye, everyone. Bye. Okay, Sagar. Bye-bye. Bye, Akila. Okay, Sagar, bye. Take care, guys.